Section 5.6, the linear programming model. What this section is about. It's basically, they will ask us to, they will give us inequality, system of inequalities, say ax plus by less than or bigger than, whatever, c. Either one of the inequality signs c. Let's say x bigger than or equal to 0, y bigger than or equal to 0, and then this keeps going on and on. This means they can give us as many inequalities as they like. And they will ask us, we will be required to find the x and y values that would either minimize or maximize a given function. So they give us a given function in x and y. Let's say capital P equals mx plus ny, something like this. Let's see. It could be plus, minus, anything. This function is called the objective function. It's called the objective function. So what is the process here? What's going to happen? First thing is we are going to graph the given inequality. And when we graph the inequality, it will give us a region, a solution region, as we saw in the previous section. So that solution region will have what we call them corner points. Sometimes the region is open, sometimes the region is closed. So we look at all these corner points. And then we're going to test those corner points by substituting them into this function one at a time, and see which one gives us the maximum value and which one gives us the minimum value. So let's look at an example, see how to do this. So let's say find the minimum. So they want us to minimize, find the minimum value of, call it z equals 3x plus 2y. That's the function, the objective function, subject to the constraints listed below. Let's see, what are the constraints listed below? X bigger than or equal to 0, y bigger than or equal to 0, x plus 2y less than or equal to 4, and then let's say x minus y less than or equal to 1. So this is similar to the inequality we did in the previous section. So let's see how to start with this one. The first one, x equals to 0. Remember from the previous section, this is really the y-axis. And bigger than or equal to 0 means you're going to shade the region to the right side. So let's say this one, I'm going to shade it in black. This is the origin. The second one is y equals 0. Y equals 0 is the horizontal line, this one, y equals 0. But it says bigger than. Bigger means the region above the line, above the x-axis. So it's this one. Next one is the straight line, x plus 2y less than or equal to 4. So what are we going to do with this one? How are we going to graph this? If you remember from the previous section, we assume it's equal here. Assume it's equal. Set x equals 0 using intercepts. Y would be 2. If you set y 0, what x would be? X would be 4. So we got 0, 4, 0, 2, 3, 4, 4, 0, 0, 2. So we're going to graph this. I graphed it as a solid line because it's or equal. So that's 4 and 2. So now this one we can pick a point. Choose or pick the 0, 0. Substitute it into the inequality x plus 2y less than or equal to 4. Test it. Okay, 0 plus 0, 4, 0 less than or equal to 4. So that's true, that's correct. So we shade the region below the line, because that's the region containing the origin. The origin is a true region, or that region containing the origin is a true region. One more inequality, and then we see x minus y equals 1. Let's check it out one more time. Yes, it is. X equals 0. Then you got negative y is 1. Pay attention to this. Y is negative 1. So that gives me a point, 0, negative 1. But if you take y 0, that gives us x equals 1. So I have another point, 1, 0. So 2 points, 1, 0. So that's the point 1, 0. The other point 0, negative 1. 0, negative 1. And then we connect them together like that. And let's see what we do. So to graph it for this one, x minus y less than or equal to 1, x minus y less than or equal to 1, we pick a testing point 0, 0. So 0 minus 0 less than or equal to 1, 0 less than or equal to 1. That's a true thing, true statement. So this means we are going to shade the region that contains the origin, and that would be this one. That would be this region. That's the region containing the origin. So where do they all overlap? Where do they all overlap? The black, the green, the red, the yellow. I see it starts with the origin to the right side, up, and then down. It's this enclosed region. See this region here. This region in the middle, I'm gonna put as a solution. So this region has vertices. What are the vertices? 0, 0 is one of them, 1, 0 is another one, 0, 2 is another one, and one last point here, that point of intersection between the two lines. So we need to list down all these 4 points coordinates. So the first one was 0, 0, the second one 1, 0, 0, 2, and again those are called corner points. And the last one is, I can see it's at 2, x equals 2, but 2 comma what? 2 comma something. Well, to find out what the y coordinate, if you're not sure about it, because I see it's exactly at 2 here, what you can do is go back to one of these 2 lines and choose either one. Let's say I want to choose the first one, x plus 2y, x plus 2y equals 4. If x is 2 plus 2y is 4, so then from here, 2y is 2, so y is 1. So that point is 2 comma 1. We're not done. Remember, we would like to find the values of x and y to minimize this objective function. Z equals 3x plus 2y. So z equals 2x plus 3y. That's the constraint function. Actually, 3x plus 2y. 3x, test it out. Yes, 3x plus 2y. So we have the points. The first point was 0, 0. Substitute in, the value would be 0 plus 0, 0. Another point was 1, 0. So z would be 3 times 1 plus 0. So that's a 3. The next point was 0, 2. So z equals 3 times 0 plus 2 times 2. That's a 4. The next point is 2 comma 1. So z equals 3 times 2 plus 2 times 1. 6 plus 2 is 8. So which one gives us the lowest value? So the lowest value, as you can see among all of them, is this one. This is the least value. Least value, as you can see. Least value. So from here, this tells us, so we can say x equals 0, y equals 0 will minimize the objective function, z equals 3x plus 2y, corresponding to the given constraint. This is important for future applications, like minimizing, maximizing profit, revenue, things like that. Another example on this, let's say we are asked to minimize, call it c of x, y. It doesn't have to be always z. 2x plus 5y subject to this constraint functions. X bigger than or equal to 0, y bigger than or equal to 0. 2x plus y is bigger than or equal to 8. So we have 3 inequalities here. Let's do it the same way as we did the previous one and see what works here for us. Okay, so the first one is x equals 0. That's the y-axis. Sorry, the x-axis. No, the y-axis. So bigger than or equal, so it's to the right side of the y-axis. We got y equals 0. That's the horizontal axis. So it's bigger than, so means it's higher. So we shade the region above the x-axis. Shade the region above the x-axis. And the last one, 2x plus y equals 8. So how do we graph this? Well, we take x equals 0 using intercepts. Y is 8. Y is 0. X is 4. So let's graph it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Somewhere down up there. It's a solid line because it's or equal. That's 4 and that's 8. Now we pick a testing points so we select this as testing point and we substitute it in the given inequality. 2x plus y bigger than or equal 0, bigger than or equal to 8. Substitute the 0 in. 0 plus 0 bigger than or equal to 8. 0 bigger than or equal to 8. That's a false statement. It's false. So the region containing the origin is not a solution. So it has to be this region here. And now we need to look at where's the region where they all overlap. So the region where they all overlap. So what are the, where is it? So I see it's this region here, this region, and I'm shading or highlighting or shading or labeling with red. So this is the solution region. So this has how many endpoints? I see this 4, 0 is one of the endpoints. 0, 8 is another end or corner points. 2 of them only, and the other space is all open. That's why this has no maximum, just so you know. But to minimize, we need to minimize the 2x plus 5y. We need to minimize c of xy, which is 2x plus 5y. Let's see how we're going to minimize this 2x plus 5y. We have 2 points. The first point 4, 0, and the other point was 0, 8. Those are the only 2 corner points that we can check here. So if you substitute 4 comma 0, that gives us 2 times 4 plus 5 times 0. 8 plus 0, 8. C of 0 comma 8. That's 2 times 0 plus 5 times 8. So that gives us 40. That gives us 40. So which one is bigger? Well, the second one is bigger. So it minimized at this one. So this is the least value. Least value. So C of xy is minimized when x is 4 and y is 0. Y is 0 from this point. Y is 0. Can they ask us this as in a word problem format? Yes, they can. So let's look at an example here about a word problem like this. So it's kind of a long problem here. You can read through it. They are talking here about tacos and burritos. So at the end, so when you read this, the manager directs the cook to use the available resources to maximize. So we're going to be maximizing. So they talk about tacos and burritos, and we would like to minimize something. How do we set that up? So let's see. First thing, they ask us to minimize the revenue for the remainder of the shift. If a taco sells for 40 cents and a burrito sells for 65 cents, as you can see, they're talking only about tacos and burritos. Then how many of each should they make to maximize their revenue? This is a very interesting problem from as a real life application. So the first thing is, they at the end here, they ask us the number of tacos and the number of burritos to maximize the revenue. So we can say let X be the number of tacos, Y be the number of burritos. Okay, the number of burritos. These tacos and burritos are made of ground beef and tomatoes. Ground beef and tomatoes. So the way to set up, if you read the problem, let me write ground beef here. So I need to set up inequalities. And tomatoes. Tomatoes. So X is the tacos, Y for the burritos. They said every 2 ounces of ground beef and 1 ounce for tacos and 1 ounce for the burritos is less than or equal. So from here you can say 2x plus 1y less than or equal 22. Yes, near closing, the cook discovers that they can have only 22 ounces of ground beef. So this means the maximum amount of ground beef is 22 ounces for both the tacos and the burritos. And this is ounces. For the other one, they said 36 ounces of tomatoes left. So this means they said 1 ounce of the tacos and 3 ounces of this. So 1x plus 3y less than or equal 36. So I got these two inequalities. And they said if the taco costs 40 cents and burrito 65 cents, so the objective function that I'm gonna construct now, call it z, it's 40x and 65y. And this is just so you know it's in cents. Okay, subject to the constraint, to the constraints. What are the constraints here? Well, x is the number of tacos, so x has to be bigger than or equal to 0. Y burritos, y bigger than or equal to 0. And that's why in all the previous examples, you saw that we wrote x and y both bigger than or equal to 0. Another inequality we just came up with, 2x plus y less than or equal to 22. And the other one, x plus 3y less than or equal 36. So we got 4 inequalities that we're going to graph. Okay, we're going to graph all of them now. The first one, I'm going to graph it here on the side. X, 0, y. This is, remember, this is the x equals 0. And it's to the right, so I'm going to graph it this way. The other one is, this is y equals 0. We're going to graph above this because it's bigger than or equal to 0. So it's above the x-axis. The next one, we have 2x plus y equals 22. So what we're going to do is, you can use y-intercepts and x-intercept, but you have to be a little bit careful. So when you take x0, you got y equals 22. This is a large number. So you can assume 22 is here. That's totally fine. When you take y0, you get x equals 11. So 11 would be half of that. So maybe somewhere here, labeled as 11. So we're going to connect this together. And then we are going to see if we pick 0, 0 as a testing point, 0, 0 as testing point, we got 0 plus 0 less than or equal to 22. That's true. So the region containing the origin is a solution. So you can shade this one. Okay, we can shade this solution, this region. And for the last one, x plus 3y equals 36. Again, if you take x0, y would be 12. And when y 0, x is 36. So x, y 0, 0, 12. So 0, 12 maybe somewhere here. Let's say 0, 12. And the other one 36, 0. So let's say it's somewhere here. So we're going to connect them with a solid line. 36, label everything. If we pick the origin 0, 0, substitute it back in. 0 plus 0 less than or equal 36. 0 less than or equal 36. That's a true region. So the region containing the origin must be shaded. So I'm going to shade this region below the line. And notice, we're going to notice where they all overlap. They all overlap here. Right? Test it out. Check it out. Make sure you got that. And now you can see what are the points that we have here. The corner points. So I'm going to write them here. Corner points. Corner points are 0, 0 is one of them. We're going to test it. 1, 0 is another one. 0, 12 is the next one. And there will be one more point of intersection between the two lines. We don't actually know where they intersect. So what am I going to do now? How am I going to find this point here? So as I said, we have 1, 2, 3, and this point. So how am I going to find the coordinates of that point? To do so, this is basically the intersection of the two given inequalities here. 2x plus y less than or equal to 22. Let me write that down. I'm going to write as equation, and x plus 3y equals 36. Let me just check it out. 36. Yes, okay. So now what we need to do is the intersection of these two equations or these two lines is the point I'm looking for, this point, the last point. So how do you do this? We can solve this system of equations. You can multiply here by -2. And let's see what we get. The first equation stays the same. We learned this in this chapter. Now I'm trying to use elimination now. -72. Add them up, these cancel. -5y equals -50. So y is 10. Y is 10. So I got y 10. To find x, you can simply substitute this back in here. So 2x plus 10 is 22. Subtract 10 on both sides. So 2x is 12. X is 6. So I get 6 comma 10. 6 comma 10. So now what are we going to do? I'm going to substitute all these 4 points coordinates into the objective function. What was the objective? 40x plus 65y. So z was 40x plus 65y. Substitute the first one. 40 times 0 plus 65 times 0. This is the easiest one to calculate. So 0. The next one, 40 times 1 plus 65 times 0. That's 40. The next one, z equals 40 times 0 plus 65 times 12. So the first one is 0. And if you substitute the 12 times 65, that's 780. And the last one, z equals 40 times 6 plus 65 times 10. And that gives us 890. Let's go back, see what we're trying to do. We would like to find the number of tacos, like what is the x and what is the y, to maximize the revenue, to maximize the objective function. The largest value you can see is 890. So they will make the maximum revenue when they make x is 6, x equals 6 tacos, and y equals 10 burritos. They will get the maximum profit. This is what this section is about.